everyone. Thank you for attending my sunroom chat. Today I will discuss diffraction in terms of vest theory. Let's begin by defining what we mean by diffraction. Diffraction refers to the curvature of photons when they pass by a dense medium. The medium could be a mountain, a wall, or any other object denser than air. Obviously, the most basic underlying cause of diffraction and refraction must be identical, because they both result in the curvature of photons as they pass by or enter into a denser medium. I explained in my previous sunroom chat that a photon enters into a denser medium and bends because its electric fields act as anchors when they penetrate a denser medium. This causes the photon to travel slower in a denser medium, and it causes the photon to bend when it passes from air into a denser medium. The photon's electric fields are virtual elastic strings that I refer to as elons. Elon anchors are responsible for refraction, and they are also responsible for diffraction, as shown in the next slide.
Here we see a photon zipping along through space, but when it passes by something solid, it curves. However, the photon only curves when it passes extremely close to the wall. We are talking about distances less than a few nanometers, less than the wavelength of light. The photon curves because its elons are ejected into the wall where they act as anchors. This causes the photon to pivot around the anchor point. This is the same explanation I gave for refraction. I should point out that this interpretation of diffraction does not follow the beliefs of mainstream scientists who argue that a photon has wave properties, and it curves for the same reason a wave of water curves when it passes by an object. However, vest theory states that the wave properties of a photon are created by its elons that are composed of matter and are ejected at right angles to the photon's line of flight. For vest theory, the question is, why doesn't the photon curve when it's greater than a few nanometers from the denser medium? The graviton matrix solves this conundrum as shown in the next slide. The yellow background in this picture represents the dense concentration of gravitons found in the space about us. I refer to this as the graviton matrix. When the photon passes by the wall at a distance greater than a few nanometers, the photon's elons are secured to the rear by the graviton matrix. Under these conditions, the elon anchors pull to the rear and not into the wall, and the momentum of the photon keeps us going in a straight line. A small AM radio photon may well curve under these conditions because its momentum is billions of times less than a photon of light. The curvature of light has been studied in detail using narrow slits in a thin wall. A simplified version of this is found in the next slide. When light is sent through a narrow slit, it spreads out as shown here. A photon curves more when it passes close to one of the walls, which explains this observation. Scientists have also shown that photons with shorter wavelength curve faster than photons with longer wavelengths. Of course, the wavelength of a photon is the distance the photon travels while it creates its two string cycles. It has no other meaning. This means photons of shorter wavelength create their full complement of anchors quicker than photons with longer wavelengths. For this reason, blue light curves faster than red light. This is identical to refraction.
Scientists have done numerous experiments with diffraction starting way back in the 1600s. It is beyond the scope of this sunroom chat to explore the wealth of information on this subject. Thank you for attending my sunroom chat. In my next slide, I leave you with a short summary of this discussion. Following that is a thought for you to consider, and my website, where you can find my book and view all of my movies in their logical order. I hope you're having a great day. Bye for now.
The following is some of the major points covering diffraction. The photon's electric strings, that is the elons, are responsible for diffraction and refraction because they act as anchors when they penetrate a denser medium. The Elon anchors cause the photon to swing around the pivot point and curve. The shorter the photon's wavelength, the greater the curvature, because the anchor points are made over a shorter time period. If the distance between photon and wall is only a few nanometers, that is less than the wavelength of light, the photon curves. If the distance between photon and wall is greater than a few nanometers, the photon continues on in a straight line because of the graviton matrix. A small AM radio photon is the exception to this statement.